Let us study about relaxation time and mean free path. To understand this, let us look at the previous discussion where we studied about free electrons moving in a conductor. We saw that if we apply an external electric field with help of a battery, then the electrons will move against the applied electric field like this. Now, if we consider a given electron, we look at electron by putting a dot to represent the electron. Now this electron may collide somewhere here, and even after collision its path will be changed, but because of the electric field the electron will be pulled in this direction. The electron will move from end B towards end A, because electrons move against the electric field. Again, it may collide somewhere here, but it is still, when pulled forward, it may collide somewhere here, collide like this. In all the cases, it has been still moved forward only. So, electron will have a forward motion always. Now, after each collision, there is a collision somewhere here, a collision here, a collision here. After each collision, let us represent the red dot as atoms or molecules. After each collision, it still keeps moving forward. So, the time taken between two collisions is not same. It will differ. So, even for one electron, the time between two collisions will vary. If we look at all the electrons' motion, then for all the electrons, the time between any two successive collision will vary. If we average all those times, then what we get is called as relaxation time. So you can say it is the time spent by an electron before it collides, or it is the average of this. So the average of all these times here mean the time between any two successive collisions. That is called as relaxation time, and symbol for that is tau. Similarly, before colliding with the next atom or molecule, an electron will travel some distance. It travels this distance here, or this distance, or this distance. These distances will not be same for an electron. Sometimes it will travel more distance, sometimes less distance, sometimes still more, sometimes less. Now, even for one electron itself, the distance between two successive collisions will not be same. If we look at all the electrons, then for all the electrons, the distance between two successive collisions will not be same. If we average it, then the average distance for any electron between two successive collision is called as mean free path. So you can say that it is the distance traveled by a conduction electron during the average time elapsed between two successive collisions. That's called as mean free path. Keep in mind that whether it is relaxation time or mean free path, these are average values for a given conductor and for a given electron. Also, both of these parameters, that is relaxation time and mean free path, both of this depend on free electron density, which is represented by symbol small n, which is called as number of free electrons per unit volume. So if n is more, it will vary. It will vary because if there are more number of free electrons, there are more collisions. And also it depends on temperature, because we saw that in case of temperature, when temperature rises, the atoms or molecules will have vigorous vibration, so there is more chance of collision. So in that case, the relaxation time as well as distance will vary.